Sometimes in exams, you'll need to come up with some identities. They will ask you to prove these. And this is a common one. So let's solve this one together. So how do you come from this one to this one? You do it by using some of the common properties to these types of problems. Let's start from the beginning. Sine of 3a is the same thing as saying sine of 2a plus a. This is the same thing. And sine of a plus or minus b is the same thing as saying sine of a cosine b plus or minus sine of b cosine of a. And now this is the important part. Notice the b here. So because we now have a, we're going to do a substitution. Let me show you. So sine a plus a, because we have plus here, this is our case. So it's the same thing as saying sine of a, but instead of having cosine of b, because we have a here, now it's cosine of a. And then it's plus, because we're just working with a plus here, so we're not working with a minus, we're working with a plus. So it's sine of a cosine of a. We did the exact same thing that we have here. The only thing that we did differently is that instead of, because we had a b, so it was cosine of b, now it's cosine of a. This is all we're doing here. And notice that both these expressions are the same, right? So sine a cosine a plus sine a cosine a. So this is the same thing as saying 2 sine a cosine a. Okay? This is the first part. So the same thing for cosine. You have cosine of a plus b. It's the same thing as saying cosine a cosine b minus sine of a sine of b. And because we have this term, but instead of a b, we have an a, we're doing the same thing. So cosine a plus a, it's equal to cosine a cosine a. So instead of having this one, we have this one, minus sine a sine of a. And if you notice both these expressions, we have the exact same term multiplying by the same term. So this is the same thing as saying cosine squared of a minus sine squared of a. So this is our second one. And because we are working with sine, we're going to use a substitution here. We know from the trigonometric identity that sine squared of a plus cosine squared of a is equal to 1. So in our specific example, since we are working with sine, this is the one that we are interested in, so we're going to change the cosine to the sine version, counterparty. And this one, so cosine here, so it's 1 minus sine squared of a. So this is what we have here, so 1 minus, and because this one comes outside, let me show you. So we have 1 minus sine squared of a minus sine squared of a. This is the second term, this is the sum term here. So we change this one to 1 minus sine squared of a, but we still have this one to take care of. So 1 minus sine squared of a again. And if you notice, because these two terms are the same, now we have 1 minus 2 sine squared of a. So this is the second one. So now that we have both these expressions, let's resume what we have done so far. So sine of 3a is the same thing as saying that we have sine of 2a plus a. So our initial expression was this one, sine of a plus b. So this is the first term and this is the second term. So we found that the first term, that is in terms of a, it's one is sine of a and cosine of a, but we needed to find the counterparty for 2a. This is what we have done so far. So sine of 2a, it's this one, and we're going to multiply by this one. And the same thing for cosine of 2a. So it's this one, so cosine of, instead of a, it's 2a, and we are going to multiply by this one. So let's do just that. So the sine of 2a plus a, it's equal to, now we're going to substitute it back, so it's 2 sine a cosine A times this one. And because right now we don't have any b's anymore, it's a. So it's this one down here. So it's cosine A. And the second term, so it's plus, this is sine B, and this is cosine A. And because the first term is 2a, we're going to use the one that we found for cosine. So it's 1 minus 2 sine squared of A. So this is cosine of 2a times the other one. So it's sine. But instead of B, because all this is in term of A, so it's sine A. Okay? So now we're just going to distribute these terms across the board. So we just have to multiply these two. So it's 2 sine A cosine squared of A plus, and then we're going to do the same thing for these ones. So this goes here and this one goes there. So sine A minus 2 sine to the third of A. If we keep going, we notice that we don't have any cosines here. And we also notice that this one, we can use a trigonometric identity in order to get to the final term. Cosine squared of A, it's the same thing as having 1 minus sine squared of A. So we have 2 sine of A, 1 minus sine squared of A, plus sine of A, minus 2 sine 3a. So if we keep going, let's just distribute these two. So we have sine 2a minus 2, 1, so it's 3, 2 sine 3a plus sine a minus 2 sine 3a. And we have these two, so we can aggregate them. And we have this one that we can aggregate as well. So this is 3 sine A minus 4 sine 3